Ma'am, I am PM Monica. My problem is bookwork 2.4 and equilibrium problem, ma'am. Bookwork 2.4. To find a resultant of coplanar forces using their components. Consider the forces F1 vector, F2 vector, and so on Fn vector acting on a particle. The resultant is F1 vector plus F2 vector plus F3 vector plus and so on Fn vector. This is equals to x I vector plus y j vector. Multiplying this scalar by I, F1 I vector plus F2 I vector plus and so on Fn I vector. This is equal to x. Now F1 vector I vector is the component of F1 vector in the I direction. So x is the sum of the component of the forces in I vector direction. Similarly for y is the sum of the component of the forces in the j vector direction. Problem 1. Five forces acting at a points are respected in magnitude and direction by the lines join the vertex of the any pentagon to the midpoint of their opposite sides. Show that they are in equilibrium. Let A, B, C, D, E be the pentagon and A dash, B dash, C dash, D dash and E dash be the midpoints of sides, the opposite to A, B, C, D, E respectively. This is the diagram. A, B, C, D, E be the pentagon and A dash, B dash, C dash, D dash, E dash be the midpoints of the sides opposite to a, B, C, D, E. Then AB vector equal to A vector, BC vector equal to B vector, CD vector equal to C vector, DE vector equal to D vector, EA vector equal to E vector. We want to prove that this all is equal to 0 vector. A dash plus B dash plus C dash plus D dash plus E dash is equal to 0 vector. A vector plus B vector plus C vector plus D vector plus E vector is equal to 0 vector. We consider this as equation 1. Then consider the forces A and A dash. A dash vector equal to AB vector plus BC vector plus C A dash vector. We know that AB vector equal to A vector, BC vector equal to B vector, then C A dash is off of C vector. Similarly for B dash, B dash vector is equal to BC vector, CD vector, DB dash vector. BC vector is B vector, CD vector is C vector, DB dash vector is off of D vector. Then for C dash vector is CD vector, DE vector, E C dash vector. CD vector is C vector, DE vector is D vector, E C dash vector is off of E vector. D dash vector is DE vector, EA vector, A D dash vector. DE vector is D vector, EA vector is E vector, A D dash vector is off of A vector. Then E dash vector is equal to EA vector, AB vector, B E dash vector. EA vector is E vector, AB vector is A vector, B E dash vector is off of B vector. We want to add all the forces summation A dash plus B dash plus C dash plus D dash plus E dash equals to A vector plus B vector plus C vector divided by 2 plus C vector plus B vector plus D vector divided by 2 plus D vector plus C vector plus E vector divided by 2 plus D vector plus E vector plus off of A vector plus E vector plus A vector plus off of B vector. We are proving this 2A vector plus 2B vector plus 2C vector plus 2D vector plus 2E vector plus A vector divided by 2 plus B vector divided by 2 plus C vector divided by 2 plus D vector divided by 2 plus E vector divided by 2. Then 4A vector plus 4B vector plus 4C vector plus 4D vector plus 4E vector plus A vector plus B vector plus C vector plus D vector plus E vector all divided by 2. We adding this all 5A vector plus 5B vector plus 5C vector plus 5D vector plus 5E vector divided by 2. Then We take 5 by 2 outside, then a vector plus b vector plus c vector plus d vector plus e vector. From equation 1, we know that a vector plus b vector plus e vector plus c vector plus d vector is equal to 0 vector. We applying that 5 by 2 0 vector. This is become 0 vector. We proved that this is in equilibrium. Problem 2. Forces acting at a point are respected in magnitude and direction by AB vector, 2 BC vector, 2 CD vector, DA vector, DB vector, where ABCD is a square. Show that the forces are in equilibrium. Let ABCD is a square. The forces AB vector, 2 BC vector, 2 CD vector, DA vector, DB vector. All the points are at a point. AB vector equal to A vector, BC vector equal to A vector, CD vector equal to minus A vector, DA vector equal to minus A vector, DB vector equal to minus A vector into A vector. This is the diagram, and A vector, B vector, C vector, D vector. These are the forces. D for square, all the sides are equal. We adding all the forces by direction. AB vector plus 2 BC vector plus 2 CD vector plus DA vector plus DB vector is equal to A vector plus 2A vector plus 2 of minus A vector and minus A vector plus DB vector. DB vector equal to A vector minus A vector divided by 2. This is become 0. So then AB vector plus 2 BC vector plus 2 CD vector plus DA vector plus DB vector is equal to A vector plus 2A vector minus 2A vector plus of minus A vector. This is become 0 vector. AB vector plus 2 BC vector plus 2 CD vector plus DA vector plus DB vector. This is equal to 0 vector. The forces are in equilibrium. Proved.